Okay, now we will start with this. What is photoelectric effect? First, we'll start with what is photoelectric effect. Okay, and I will try to explain what Albert Einstein's achievements or his contribution towards physics. So Albert Einstein was okay. So number one, I'll start explaining about Albert Einstein. So Albert Einstein, he was actually a Jew and born in Germany. Okay, so he was born in Germany. This guy, and after that he went to London, and then from there he went to US. He got the nationality of US. Okay, so that is how he became opposite to Hitler at that time. Okay, anyways, we are not going to history. Okay, so he in 1905 he published 3 papers. Year 1905 is known as year of physics. It's not the date of birth. Okay, year of physics. Why year of physics?
Because it was 4 papers he published.
Yeah, 3 international papers, 3 famous papers. What are they? Number 1, he published about the photoelectric effect.
Special relativity, Brownian motion.
Brownian, very good. The second one is E is equal to mc square, and third one is Brownian motion. Brownian motion. These are the 3 papers which were published in 1905. In 1906, he published special theory of relativity. Special theory of relativity. In 1906, he published the paper that is special theory of relativity. Now, in photoelectric effect, he got his PhD. His PhD he got in photoelectric effect, and also he got the Nobel Prize on the same subject, same topic. In around 27 something, he got the Nobel Prize on photoelectric effect. Actually, he was supposed to get on special theory of relativity, because what is special theory of relativity? See, if any particle is moving with a speed comparable to the speed of light, I mean, like 25% the speed of light, means 0.25 in 0.2 the speed of light, or 0.5 the speed of light, or 0.9 the speed of light. Have you seen this movie, Angels and Demons?
Yes, sir. Yeah.
Angels and Demons.
Yes, sir. I've seen the movie.
Okay. In that movie, in the beginning, have you seen that there are large hadron colliders where the particle goes with a speed comparable to the speed of light? In the beginning.
Yes, sir.
In the beginning of the movie. Exactly the same. See, special theory of relativity means when a particle is going with the speed comparable to the speed of light, you cannot apply your normal mechanics. You cannot apply Newton's mechanics. Normal mechanics is Newton mechanics. We have 3 types of mechanics now. One is Newton's mechanics, one is Einstein's mechanics, third one is quantum mechanics. So for big bodies, we use large bodies or any body particle, we use Newton's mechanics. But you cannot apply Newton's mechanics for any particle which is moving with the speed of light, because its mass, length, and time will not be same. The problem is with the variables. So that is why you have to apply special theory of relativity. In that time, no one could understand what is special theory. So they awarded his Nobel Prize on this concept. Anyway, let it go. So based on this phenomena, we have 3 big laboratories buried inside the ground, very deep inside the ground. One is in Russia, one is in Europe, and one is in America. They are like around 30 kilometers deep inside the ground, and the perimeter is around 25 kilometers or 20 kilometers around, 23 kilometers. one is in Sweden, one is in Russia, border of Sweden or something. One is in Russia, and one is in America. So these 3 laboratories, they are again connected with each other. So any particle, they are in collaboration. So any particle they find out, immediately they are shared with that. It is shared with the other laboratory. This is said to be high energy physics laboratories. Okay, that is what his contribution is. Okay. Now, anyways, we'll go back to photoelectric effect. We start with the photoelectric effect. So year 2005 was also celebrated as year of physics. Year after 100 years of his papers publication. The 2005 year was celebrated as year of physics. Now, what is exactly photoelectric effect? So what happens when light, once again, when light of certain frequency is made to incident on a surface, metallic surface, then electrons are ejected out. This phenomena is known as photoelectric effect. This phenomena is known as photoelectric effect. Once again, I write the definition. Please copy this fast. Then I write the definition of photoelectric effect. What is work function? What is threshold voltage? Threshold frequency. Okay, this I will tell you. Is that clear?
Yes, sir.
Come to this now. Okay. So can I erase this one, this part?
Yes, sir.
Yeah, okay, thank you. So now, first I will write the definition of photoelectric effect, then work function. Okay, so photoelectric effect. So photoelectric effect, it says, when light of certain frequency, when light of certain frequency, when light of certain frequency is made to incident, on a metallic surface, electrons are ejected out. Electrons are ejected out. This phenomena is known as photoelectric. This phenomena is known as photoelectric effect. This phenomena is known as photoelectric effect. Okay. Now, what happens? I'm drawing the figure also for you again. So when light of certain frequency is made to incident here, h nu, electrons are ejected out. This is having kinetic energy. And here we say work function. What is that? Work function is phi. Phi is said to be the work function. Phi 0. Okay, here phi 0. I'll write what is phi 0. Yeah. When light of certain frequency is made to incident on a metallic surface, electrons are ejected out. This phenomena is known as photoelectric effect. Okay. So this is the h nu is the frequency of the incident, energy of the incident radiation. H is Planck's constant. Nu is the frequency of incident radiation, and there is kinetic energy. And this is the work function. I'll write that also. Is it done? Yeah, this one. Is it done?
Just 1 second, sir.
Oh. Please write a message in the group to join. Okay. Okay, going to the next definition, that is work function now. Okay, so I'll write what are those values. Okay, so h nu. Okay, h nu. What is h nu? H nu is the energy of the incident radiation. Energy of the incident radiation. Energy of the incident radiation. What is h? H is Planck's constant. H is Planck's constant. The value of h is 6.624 into 10 to the power of -32 joule second. And nu is what? Frequency of incident radiation. frequency of incident radiation. Frequency.
No, this is h nu is equal to h nu naught minus half mv square.
Yeah. So here, what is kinetic KE? That is kinetic energy of the electron, or emitted or ejected electron. Emitted electron. Okay. Kinetic energy of the emitted electron. And what is phi? Phi is phi 0 is said to be work function. What is work function? I'll write the definition. So work function is the minimum energy. Work function is the minimum energy required by an electron. The minimum energy. The minimum energy required by an electron to escape from the metal surface. To escape from the metal surface. Is known as metal surface. Is known as work function. This is a definition of work function. So, so what is that? Once again, we have h nu, that is h nu, energy of the incident radiation. H is what? Planck's constant, 6.624 into 10 to the power of minus 32 joules second. And the nu is frequency of incident radiation. A kinetic energy of the emitted electron or ejected electron. Phi 0 is said to be work function. Work function means the minimum energy required by an electron to escape from the metal surface. Means what happens? Electron is in the inner levels. So if you give first, whatever the energy we give, first electrons will take that energy, come to the surface. If it is having enough energy, more extra energy, then with that extra energy, it will fly away in the air. That is said to be kinetic energy. Is that clear? Once again, when light incidents on the surface, metallic surface, so first of all, what happens? The electron which is now inner level will first come to the surface from inner level to upper. So that you require some energy for that. That is work function. And if the energy is more, then what happens? It will fly away in the air or in the atmosphere. Okay. Please note all this. Then we'll go ahead with the next definition. That is threshold frequency. Threshold frequency. Is it done? Yeah. Can I raise this and write threshold frequency now? Yes, sir.
Yes, sir.
Okay.
Yes,
So,
sir.
okay, I'll just write erase this much one. Now, I'll write the definition for threshold frequency. Threshold frequency. That is mu zero. Okay. What is threshold frequency? The minimum frequency. The minimum frequency of incident radiation. The minimum frequency of incident radiation for which electron emission takes place. Electron emission takes place. Okay. Here, the minimum frequency of incident radiation for which electron emission takes place. So that is said to be threshold frequency, mu zero. Okay, it doesn't happen for every color light. Suppose, see, we have here we have UV region, here we have visible region, here we have infrared region. Example. Visible means we can see with GR colors. Okay, with GR colors. With this color light we can see still, but UV and IR we cannot see. So I'm taking the example of visible region or visible light. Suppose red color light is made to incident. Example, like red color light is made to incident on the metallic surface, but electron did not come out. Electron did not come out. Even though you increased the brightness of the light, electron did not come out. The second time you incident orange color light on that. Okay, electron did not come out. Even you increased the brightness of the light or intensity of the light, then also electron did not come out. Third time you incident yellow color light, electron came out. That frequency is known as threshold frequency. Understood? That frequency is known as threshold frequency. Why? Red color is having low frequency, violet is having high frequency. Is that clear? Red is having low frequency, violet is having high frequency. Is that clear? Is that
Yes,
clear
sir.
with you?
Yes, sir.
Yes, sir.
Yeah, please note down this definition. Then I'll write the definition for photosensitive surface, photoelectrons, and photoelectric effect. Okay. So here there are the electrons, and that is we have photoelectrons, photosensitive surface. Photoelectrons means electrons in photoelectric effect. Electrons in photoelectric effect phenomena or effect is known as photoelectrons. The next one is photosensitive surface. Photosensitive surface. Photosensitive surface means the surface which is used for this purpose. Surface used for this purpose. Used for this purpose. For this purpose is known as photosensitive surface. Third one is what? Photoelectrons. Photoelectric effect. This phenomena is known as photoelectric effect. Photoelectric effect. Once again, the electrons in this which are coming out are known as photoelectrons. Surface is known as photosensitive surface, and the effect or the phenomena is known as photoelectric effect. Now, I'll quickly explain this experiment which was pending. Okay. Now, see experimental study of photoelectric effect, which was demonstrated by Albert Einstein. So, what he told, he has taken a vacuum evacuated tube. This tube is vacuum evacuated tube. Okay. Now, this tube is known as vacuum evacuated tube. Vacuum evacuated tube. This tube is known as vacuum evacuated tube. Now, what happens? This window is known as quartz window. It's a transparent, okay, quartz window made up of glass or quartz. So, what happens when light? Now, okay. So now what happens is this is a vacuum evacuated tube. Now, when this is the source, when light incidents here is made to incident on the quartz window, light enters and it hits the cathode surface, okay, or the metallic surface, and electrons start coming out. Now there is nothing in it. Okay, as I told you, if you take any gas in it, then what happens? Ionization starts happening. So we are not taking any gas in it for time being. Now, what happens is, now this is a commutator. Now we have, okay. Yeah. So, now what happened is, this is a commutator. Commutator means, two-way switch. Have you seen two-way switch?
Yes, sir.
Huh?
You talked about it before in class.
Yeah, this is a two-way switch. Okay. Now there is a voltmeter, there is a ammeter, and there is a rheostat, and this is a battery. Okay. So Now what happens is a two-way switch. This is a micro ammeter, this is a voltmeter, a rheostat, and this is a battery or a cell. Then now what happens, you see, I am not going to give any energy, but only thing is I want to make this as negative and this as positive. If I don't do that, the electrons which are coming out will go here and there. There is no accountability. You understood? We don't know how many electrons are coming out, for how much light, and all we don't know. So accountability is required. For that purpose, we made this as negative with the help of a positive and negative plate of the battery. Is that clear? Not for the purpose of the electrons. Got it? I want to make it one positive, one negative for that purpose. Is it clear? Is this clear? Okay.
Yes, sir.
So not for
Yes,
the,
sir.
it is in the mind, it is purely to make one positive, one negative. There is no other purpose like for the flow of electrons and no. It's only purely to make one positive and negative, one negative. Now electron incidents on this, electrons light incidents on this one, and electrons comes out. Okay. This surface is known as photosensitive plate of photosensitive surface. Now this is a commutator, split ring commutator means double switch. Okay, double switch. Or so now voltmeter is connected in parallel because we want to see how much is the voltage. See, suppose if you don't want to use this directly, you can use a variable battery. You understood? In the textbook, he has used rheostat. Sir, I don't know. I don't like rheostat. I want to go with a variable battery. It is very easy for me. No problem. Just replace with, if you don't use, remove this and replace with variable battery. Finish. Got it. That is how we do experiments in higher levels. The circuit diagrams are given in the textbook, but we don't use something. We change it. We change the resistance value. We will see what will happen. Now, so microammeter, there is a voltmeter, there is a rheostat, and they connected to a battery. And this is the commutator ring. Is that clear? Now, what happens is we are going to study about this experiment now. Okay, so this plate is photosensitive surface. This is vacuum evaporative. This is quartz membrane. Is that clear? Please copy this diagram fast. Then, quick. Okay, shall I erase this part? This one, the other end. Yes.
Yes, sir.
Okay. Now, the first one is effect of intensity of light on photocurrent. Effect of intensity of light. Intensity of light on photocurrent. Photocurrent. So, effect of intensity of light on photocurrent. Now, suppose this is the graph. Now, here we have intensity of light versus intensity of light versus photocurrent. Now, if you see this graph is like this. What is the meaning of this? As the intensity of light is increasing, the photocurrent is also increasing. Is that clear? As the intensity of light is increasing, the photocurrent is also increasing. It doesn't mean that for every light. Keep that in the mind. It doesn't mean for every light. Like red color light, I told you. Even though I increase the intensity, first of all, I started with red color light, I increased the intensity of red color light. Electron did not come out. First of all, it depends on the frequency. Second, it depends on the intensity. Keep that in the mind. First, it depends on frequency. Like suppose, again I will explain. Suppose what happened is with GR, I'm taking with GR because it is easy for me to explain. If I go in IR region and UV region, it's very difficult for me. You will not understand. That's the reason. Now, I took red color light first. I made red color light incident on the surface. Electron did not come out. Is that clear? Electron did not come out. Clear?
So because it's not yet met the threshold frequency, that's why.
Yeah, very good, exactly. So what happened is I took orange color light, I increased the intensity of light, nothing happened. When I started with yellow color light, now electrons started coming out. Now what I did, I increased the brightness of the light. How do I increase that? So there is a lamp. like variable, same like the rheostat is there. The same thing like that. It will be like a rheostat. A bulb will be connected of 20 or 30 watt. 30 watt bulb will be there from 0 to 30. So as I'm increasing the intensity of light, the number of electrons also start coming. More and more electrons start coming out. That is known as photocurrent. What is photocurrent? The current which is flowing through the circuit in photoelectric effect. The current which is flowing through the circuit in photoelectric effect. That current is known as photocurrent. Is that clear? Is that clear? So I'll write the thing here. So the number of photoelectrons emitted per second. The number of photoelectrons emitted per second is directly proportional to the intensity of incident radiation. Incident radiation. Here, the number of photoelectrons emitted per second is directly proportional to the intensity of incident radiation. Clear? So this is the conclusion of this graph. First graph. There are total 4 graphs in the first graph. Out of 4 graphs, all the 4 graphs are very, very important. Definitely one question will come from these graphs. Either you have to explain it. They will ask you like this. They will not give any graph. They will ask, explain the variation of intensity of light with photocurrent, like that. So you have to able to draw the graph and you have to explain this thing. Sometimes it can be asked in 1 marker. Sometimes it can be asked in 2 markers. So 1 mark scope is not there because we have only MCQs and all. Okay. So shall I go with the next one?
Yes.
If you're not able to write it, just take the screenshots at least. If you're not having the patience or if you're still feeling sleepy, just take the screenshot. Later on, you can copy it. Okay. I'll be checking the notebook next week before you leave. Okay. Maybe on 28, 29 something. When are you leaving? 28 or 29?
For the trip?
For Dubai, that safari park.
We are leaving on 28th, sir.
28, Monday. Okay. Monday they asked me to come, but I don't know whether I'll be joining or not with you people. We'll see how it will go. Because I have Ignited Minds exam on Tuesday.
Okay, sir.
Is it done? Can I erase this one? This part? Yes, sir.
Yes, sir.
Very good. Chalo. Now, the second graph. The second graph, it says effect of potential on photoelectric current. Effect of potential on photoelectric current. Effect of potential on photoelectric current. Now, see here, what is the thing that we are doing here in the second part? In the second part, see the example, if the voltage here is minus 5 volt, example, and this is plus 5 volt. Okay, what we are doing is we are decreasing the voltage of this, potential of this. If it is difference, we say potential difference or voltage. Difference between this and this is known as potential difference or voltage. But if you are speaking about only one plate at one time, if you are speaking about one plate, if you are speaking about only one plate at one time, then we say potential. Okay, positive potential, negative potential. Now we are decreasing the potential. 4 plus 3 plus 2 plus 1, 0, minus 1, minus 2. We keep on going like this. Is that clear? We are not touching this one. For that purpose only we are using commutator. You understood now? You may be asking, sir, earlier why did you take this commutator and all? The purpose of commutator and this thing is only because of this for changing the potential of the anode. So now I am going to change it now, +5, +4 like that. Okay. Now, so I am going to draw this one here, the graph. See here, the first graph. It is like this. Now this is 0. This is photo current. This is photo current and collector plate potential. Photo current, and this one is collector plate potential. Collector plate potential, and this one is retarding potential. This thing is retarding potential or stopping potential. So what will happen? Now see here, I am decreasing the potential of this plate, like +5, +4, +3, +2, +1. This is very, very important. This question is many times asked in the exam. So what I am doing here is I am decreasing the potential of the anode. Then what happened? Then the photocurrent started decreasing, but it did not become 0. The value did not become to 0. See, at 0, when the potential was 0, then also the collector was receiving the electrons. When the plate potential was 0, then also it was receiving the electrons. Then when I started making it negative, like -1, -2, like that, then at a particular point, the potential became -V0. What happened? It became 0. That means the anode started rejecting the electrons. It did not take the electrons. It's not owning the electrons now. Once again, see what happened is when it was +5, it was maximum. Okay, it was maximum. Now what happened? We started decreasing the plate potential of anode. When it started decreasing, it became slowly came down the photoelectrons. But at 0, still it was receiving the electrons. Anode was receiving the electrons. But when it started making negative, it's still, but at particular voltage or potential, like -2 or -3, it became 0 because this is negative, this is negative. It started rejecting the electrons. It was rejecting the electrons. So that potential is known as stopping potential or retarding potential. That potential is known as stopping potential or retarding potential. This was for one particular intensity, like yellow color light. I have taken the first intensity. Now I did again same experiment for the other intensity. So what happened? It became like this. This is I2. Brightness has increased. Now again the brightness was increased like this. See, this is I3. Understood now? I1, I2, and I3. Is that clear? So we have I1, we have I2, and I3. So all the intensity I3 is greater than I2 is greater than I1. So even though I increased the intensity of yellow color light, but there was no change in the stopping potential. Means what? We came to conclusion that whether you increase the intensity or decrease the intensity of that particular frequency of light, the stopping potential is fixed for one frequency. Is that clear? The stopping potential or the retarding potential is fixed for one color light, whether you increase the intensity or decrease the intensity. When I speak intensity, it means the brightness of the light. Is that clear? Is this clear? This graph, is it clear all of you? Yes.
So x-axis is voltage.
I'm not getting you. Can you please be louder?
X-axis is voltage, right?
X-axis is collector plate potential. I'm not speaking voltage. Voltage when difference. Speaking about only one plate potential. Got it?
Got it, sir.
Yeah, understood. When only one boy, only one girl is individual. When they come together, couple. Is it not?
Yes, sir.
Yeah, the same. Got it now? So it is only, we are speaking about only plate. Then that is collector plate. Sorry, plate potential. Okay. And this.
So this is with respect to infinity, right?
What is it?
So this is with respect to infinity, right? The
No.
voltage measured.
Yes. When we speak about only one potential, one plate, then that we tell as potential. Is that clear?
Okay.
Yes, that means if you are speaking about two plates difference, then that is known as potential difference. Got it?
Okay, yes, sir. Yes, sir.
Okay. Maybe we don't say with respect to 0. Sorry, with respect to infinity, we say with respect to 0. Got it?
Okay, okay, yes,
Or
sir.
with respect to ground, we can say. If you really literally want to go with a terminology, with respect to ground, you can say 0, which we use for semiconductor.
Yes, sir.
Okay. So I'll write the definition here for stopping potential also. Okay. So stopping potential is the minimum negative retarding potential. The minimum negative or retarding potential. The minimum negative retarding potential V0 given to the plate A, V0 given to the plate A, for which the photocurrent stops, for which the photocurrent stops, for which the photocurrent stops or becomes 0 is called, or becomes 0. This is known as what? This phenomena is known as, I'm just erasing this part. Okay, this phenomena is known as retarding potential. There are 3 names: retarding potential or stopping potential, retarding potential or stopping potential, or cutoff potential. Cutoff potential. Retarding potential or stopping potential or cutoff potential. Is that clear? Once again, the minimum negative or retarding potential V0 given to the plate A, for which the photocurrent stops or becomes 0 is known as retarding potential or stopping potential or cutoff potential. 3 names are there for this. 3 names are given to this. I think now this is not required. I can erase this figure. Okay. Now here, that is we have maximum kinetic energy. K max is equal to what? E into V0. What is V0? V0 is the stopping potential. Now, for a given frequency of incident radiation, given frequency of incident radiation, the stopping potential is independent of the stopping potential is independent of its intensity. Now the third graph, that is effect of frequency. Third one, effect of frequency. This statement can be asked as assertion and reasoning. This thing can be asked as assertion and